I work for a physical security group, and we try to design barriers to mitigate explosive threats. And that's what this work is for in this particular case. We're protecting the nation's different infrastructure from explosive threats and other high-level threats. In this simulation, a thin-walled structure is being acted upon by the blast from a nearby explosion, and we're interested in how the barrier comes apart, the size of the fragments, and how fast they're going. And because the steel is so thin in this barrier, it's very difficult to resolve. We have to have approximately 12 computational cells through the thickness of the barrier. This particular calculation is difficult because the explosive charge is kind of at a medium distance. If it's very close to the object you're interested in, it's easy to do the calculation. If it's very far away, you can use other types of codes, Lagrangian codes, and it has a smaller computational footprint. But for these medium range type calculations, what happens is as the barrier comes apart, it turns into confetti, and you have a mixture of steel fragments and explosive gases interacting with one another, and they can only be handled with an Eulerian code, which is very computationally expensive. This is a 32,000 core calculation. It took approximately a week of machine time to finish. And it was one of the very first calculations run on Cielo. With the Cielo, it allows us to look at a bunch of different scenarios without actually testing, and we can narrow down various threat scenarios and barrier designs to a small number that we can then go test.